Okay, the next problem then, let's do number 11. If we compare, we're in this column because the biggest number is underneath x, which is a equals 8 in this case. So if we want to sketch this by hand, it's centered at the origin. Now a is 8, which is 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. And then B is the semi-major axis, which in this case is 6. 1, 2, 3, 4, 5, 6. So this would be the ellipse right here. Next problem wants to find the center, vertices, and foci of this ellipse. If we look at this one, the bigger number is the major axis, which in this case A is 5 and B is 4. So the center is at, if you compare to this formula right here, h and k is the center, which in this case is -1, comma 2. And then the vertices are right here. They're at -1 plus or minus a, so plus or minus 5, comma k, which k is 2. So 1 plus 5 would be -1 plus 5 would be 4, 2. And -1 minus 5 would be -6, 2. So here are the vertices. And the last thing we need to find is the foci. So those are right here. H, which is -1, plus or minus c, which we need to find, comma 2. Now to find c, we're going to use the Pythagorean relation again. A squared is 25 equals b squared is 16 plus c squared. So once again we get c squared equals 9, so c equals 3. So here's our foci, -1 plus 3, which is 2, comma 2, and -1 minus 3, which is -4, comma 2. Okay, the next problem wants us to put this conic section in standard form. So we're going to collect the x terms and the y terms. So first I have the x terms, -9x squared minus 18x. I'll leave a little space. And then I'll do the y terms, 4y squared minus 8y. And I'll move the 41 over to the other side as positive 41. Now I'm going to factor out some things. I'm going to factor out -9 from the first here, and I get 2x. And I'm going to still leave the space. I'm going to factor out 4 from the next one, and I get this. I'm still going to leave a space, and that equals 41. And then from here, I'm going to complete the square. So completing the square, I add b over 2 squared to both sides, which is 2 over 2 in this case, which is 1 squared, which turns into 1, but then I need to multiply by -9, so I need to add -9 to this side. And then for this one, I need to add b over 2, which is -2 over 2, -1 squared, which is just positive 1. Positive 1 times 4 is positive 4. So then this factors, I have -9, this turns into x plus 1 squared. This is 4, and this turns into y minus 1 squared. And then I have 41 minus 9 gives me 32, plus 4 is 36. And we can then divide through by 36. And then put this in standard form. So now in standard form, this goes in 9 times, this goes into this 4 times. I'm going to write y first, so it's going to be y minus 1 squared over 4, over 9, minus x plus 1 squared over 4 equals 1. That's a hyperbola, and obviously you could sketch this. It's shifted over 1 unit to the left and 1 unit down, 1 unit up rather. So if I want to quickly sketch this, we could get the formulas out. And we have y that comes first, so the focal axis in this case is x equals h. In this case, our h is -1. So we have x equals -1. That means the focal axis is this vertical line. So this thing's going to open up or down. And the center is at hk, which is -1, comma 1. So our center's -1, 1 right here. And from there, you know that a is 3 and b is 2, and we can go up 3 because a is 3 to get to the vertices here, and down 3, 1, 2, 3, and then we go over 2 for b, And what that does for you then, if you make a box, the asymptotes for the hyperbola go through this box. So the asymptotes go like this. And you get this hyperbola right here. Okay, next question says how many different license plates begin with 2 digits followed by 2 letters and then 3 digits. We have 2, then we have 2, and then we have 3. So these are digits, so we have 10 to choose from, but we can't repeat, so we have 9 then left. These are letters, so we have 26 to choose from, and then we can't repeat, so 25 to choose from. And then here we have 8, 7, 6. So we're going to multiply these all together with the multiplication counting principle. The reason it's 8, 7, 6 here is because we can't repeat those numbers. So that would give us 19,656,000. Okay, next one, we want to find the coefficient on the last term here. So, or on the 11th term, I guess, this term right here. So what we want to do is start writing out the binomial theorem, which is 14c0. The first term would be x to the 14th, and then y to the 0th. But we want to get it to where this is going to be 3, so that it matches this, and this is going to be 11. So that's down to whatever term number that is. That's what we want. And they just want the coefficient, which in this case is easy. It's just 14c3, which is 364. Okay, one more then. The x to the 7th term in this binomial expansion would be 11c0 for the first term, x to the 11th, and then negative 3 to the 0th. But we want this to be a 7 right here, in which case this would be a 4, and this would be a 4. So to get that one, we'd have to do 11c4, and then I have to bring this number out front. So it'd be times negative 3 to the 4th, which is a positive number, and overall that gives you 26,730. Okay, the next problem says that Doll Calculators knows that a unit come off an assembly line has a probability of 0.037 of being defective. So I'm going to call that my probability of success, 0.037, and my probability of failure then would be 1 minus that. Now you could switch this around, but I don't know why I'm calling this defective, and this is not defective. I feel like it's a little confusing. Might be a simpler way to do this, but use the binomial probability theorem then, because you have 2 possibilities, defective or not defective, and we're doing this 4 times. So it's 4c, in this case 4, probability of success 0.037, we want 0 of those, and probability of failure 0.963, we want 4 of those. So it's just really that term in the binomial expansion, and that gives you 0.86, or 86%. Okay, the next problem here gives us a sequence and asks if it converges or diverges. You can kind of tell these numbers are getting smaller because the bottom numbers are getting bigger. In fact, you can write this out if you look at it long enough. It's actually 1 over n squared, where the first term is 1 over 1, second term is 1 over 2 squared, and so on. This thing is going to 0, so you know the bottom's going to get bigger and bigger until eventually. So we could say the limit as n approaches infinity of this thing is going to go to 0. So that's our answer right there. You can graph it and look at it as well, but you guys kind of remember the function 1 over x squared as an exponential decay function. Okay, next let's do 21 right here. Looks like we're adding 4 each time, so the common difference would be 4, and our first term is 6, and they just want us to find, well, we got the common difference, let's find the 10th term. The arithmetic sequence then is the first term plus n minus 1 times the common difference. First term is 6, n minus 1 times the common difference of 4, and if we distribute that, we get 4n plus 2. And then if we wanted to find the 10th term, plug in 10, and you get 38 then. So the 10th term would be 38. And the next thing wants a recursive formula. A recursive formula starts off with our first term, which our first term in this case is 6. And then it's saying what's happening to a sub n plus 1 in terms of a sub n. Well, what we're doing is we're taking a sub n, and each time we're adding 4 to it. So this basically means take a term, add 4, and you get the next term. There's different ways to write it, but that's how we would write the recursive formula. And the explicit rule for part D I already wrote, which is right here. Okay, the next term says the first row of seating has 7 seats, and then obviously it says there's 25 rows of seats. Now it says each row contains 2 more, so the second one's going to be 9, and the third one's going to be 11, and you get the pattern all the way up to the 25th row. They want to know how many seats are in the entire section. So that's going to be a series because we're going to add all these terms up. So this is arithmetic where the common difference is 2 and the first term is 7. So let's first of all write the sequence. We don't really have to do this, but the sequence is a sub 1, which is 7, plus n minus 1 times the common difference of 2. We can distribute the 2 and we get 5 plus 2n, so 2n plus 5. There's our sequence. So we can do this in the calculator if we want, 2n plus 5 as n goes from 1 to 25, or we can use the formula on the formula sheet for the sum of the series, which is n times a sub 1 plus a sub n over 2. So the total number of terms is 25. First term is 7. Last term, the 25th term, I'm going to find by plugging in 25 right here, in which case I get 55. And then all divided by 2. And that gives us 775. Okay, I'm going to jump back into a couple problems that I've skipped. This one's from chapter 9. This one says that lunch consists of an entree, 2 vegetables, and a dessert. And it says there are 4 entrees. So we're going to choose 1 entree from 4. So what we need to do is 4C1 here. That takes care of the entrees. Now the vegetables, there's 6 vegetables. We're going to choose 2, so that'd be 6C2. And then there's 6 desserts, and we need to choose 1 dessert, so that'd be 6C1. That should be our answer, which is, so we're picking 1 entree from 4 where order doesn't matter, and then we're picking 2 vegetables from 6 where order doesn't matter, and then 1 dessert from 6. So this is the answer right here, which turns out to be 360. All right, then the last problem, when you multiply 2 complex numbers together, these are in trig form. What you do is you multiply, so the formula is right. So it's 5 times 3, which is 15. And then you have cosine, and then we need to add the angles together. So I have pi over 4 plus 5 pi over 3. Want to get a common denominator, multiply top and bottom of this one by 3, and multiply top and bottom of this one by 4, and that gives me 3 pi over 12 plus 20 pi over 12, so that'd be 23 pi over 12. And that goes in for both of them. And then the last problem, if we want to find the trigonometric form of a complex number, we graph it in the complex plane. So we graph the real part on the x-axis and the imaginary part, which would be 2 square root of 3 on the y-axis. And we can make a triangle out of that, where obviously this is 2 square root of 3, it's supposed to be a 2. And then for polar form, or I'm sorry, trigonometric form, it's r cosine of theta plus I sine of theta. So all we need to do is find r, which is the hypotenuse here, and the angle theta, which is technically this angle. So what we're going to do is we're going to use special right triangles, because I noticed that this is s square root of 3, and this is 2s. It's a 30, 60, 90 triangle. Recognize that pattern, where s is 2, in which case this is 4. So my r is 4. And then my angle then this is a 60-degree angle right here in your special right triangle. And therefore this is 120. So we can do 120. And it does want radians, because it says from 0 to 2 pi. So I'm going to quickly convert 120 degrees to radians by multiplying by pi over 180. And that gives us 2 pi over 3. 60 goes into this twice and into this 3 times. So I'm going to do 2 pi over 3 instead. Now, there's different ways to do this problem, obviously. You know, you could just use like inverse tangent to find that angle. But if you notice it's a special right triangle, I think that's quickest. But there's your trig form of a complex number, and you're all set.